Hello everyone. So today we are going to see maximum number of occurrences of a substring. So we are given an input of a string S and three integer values, max letters, min size and max size. So we have to return the number of substrings we can form from the string yes. But the substring can be formed with following rules. The rules are the number of unique characters in the substring must be less than or equal to max letters, and the substring size must be between min size and max size. Let's understand the problem statement with an example. Here is our first example. So we have to form substrings that satisfies these conditions. So let's consider our string A, B, and A, B, C, and A, B. So the minimum size must be 3. So let's start considering the first three characters A, B, and the size is 3, and the maximum letters used here is 2. So this substring satisfies the condition. Next, start from the second character and the next three will be the minimum size. And it does satisfy the condition, that is 2 maximum characters and minimum size of 3 and maximum size of 4. So now B occurs one time and A occurs one time. And the next substring is BAB. Again, this satisfies the conditions. So BAB also occurs one time. So the next thing is ABC. This is not satisfying the condition since the letters used are 3, but the maximum letters should be used are 2. So ignoring that, moving on to the next character from BCA. Again, this is not satisfying the condition. The next substring is CAA. So this is satisfying the condition. So the next is AAB. So AAB has already been occurred in our set of substrings. So we just increment the count to 2. So now the string ends. So if we compare, AAB occurs twice. This is the maximum occurrence out of all substrings we got. So our output is 2. So this is our problem statement says. So now we are going to approach this problem statement in two ways. That is, we're going to have two different algorithms explained in this video. So let's see our first algorithm. Our first algorithm is the same method I explained previously. That is, we're going to consider a substring of min size and check whether it satisfies all the conditions, and if it satisfies the conditions, we are going to add it to a hash map and its occurrence. So once we populate all the substrings with its occurrence, finally we are going to check which is the maximum and return the value. So simply in our algorithm, we're going to iterate through the string from 0 to n minus min size. Why? Because in the last min size, if we consider this substring, there is no elements left to add to the substring. So we are going to iterate until this only, so that we just move the pointer to check all possible substrings of size min size, and then check if that substring satisfies all the condition or not. If the substring satisfies all the condition, then add it to a hash map, that is the substring comma its occurrence. So when we find the repeated substring, we're gonna increment its count, and also we have gonna have a value result where every time a new substring is added, we're going to compare the result value which is maximum. If the result is maximum, we leave it, otherwise we're going to update it with a new result. So this is how we're going to do our algorithm. Let's see the code now. Here is our code for the problem I explained. So at the first line, we are simply checking the basic conditions, whether the length of the string is 0 and max letters is 0, then return 0. If not, we are declaring a hash map to store the substring and its occurrence, and through the loop we just iterate it till length minus min size and take the substring from I comma I plus min size. That is, we are going to check the substring of min size, and we are having a method is valid, which will return a boolean value. If it is valid, true, then put the value to the hash map and increment its counter if it occurred already, and side by side we calculate max value, and the end we return the max value. Inside this valid method we have a hash set where we're gonna add the characters. We convert the string to the substring to the character array and add the characters to the hash map. As we already know, hash map will save only unique characters, no duplicates will be saved. So by the end, if the size of the hash map is less than or equal to max size, then it satisfies the condition 1. And the length of the substring is less than or equal to max size, then this condition as well is satisfied. So it returns true or false according to that. But there is no need to check max size in this case at all, because anyways we are considering the substring of size only of min size. So there is no option to for it to go more than the min size. In the algorithm we have discussed, we just consider the string of size only of min size, but there will be no test case fails, because for example if you consider the min size is 2 and the string we get will be AA, and AA occurs twice in the string, that is again equal to 2. So it is considered it is of size 2 or 3 or 4, the occurrence is gonna be same. So instead, if we don't want this method to follow, we have another method which is a two-pointer method or a sliding window method that will consider substring of each and every length and then find its occurrences. Let's see that algorithm now. So here is our second approach, which is a two-pointer approach or a sliding window approach. In our previous algorithm, we considered substrings of only of min size, but here we are going to consider substring of size starting from min size ending with max size between any length. So let's have two pointers at our first character. That is, I'm having my I and j here at our first character. So my I moves for every iteration. It is a scanning element which moves to check every character in the substring. So this j is gonna determine from where to where our substring resides. So simply I'm gonna check whether from first I to j whether it forms the substring that satisfies all three conditions. If it satisfies, I'm going to add it to the hash map, that is the substring and its occurrence. As usual, at the end, I'm going to check which is the maximum substring and return the result. But the method to check is a bit different here. That is, once the substring is not formed, then move the pointer I to the next character and check whether from I to j it forms a substring. Again, if it is not satisfying, move the pointer again. If it formed a substring, then instead of moving I, move the pointer j to the next element to check whether any other substrings present in between. And we're gonna get two elements help. That is, the one is the integer value letters, which is gonna count the number of letters in that particular substring to check whether it satisfies the max letters condition or not. And to help counting these letters, we're gonna have an integer array count, which helps to count the number of characters in that substring. So let's go for a dry run of this algorithm using this example and see how we can code it. As I said, we're going to keep track of few variables. The first one is an integer array ch, which is going to have the character count. So we are going to initialize the integer to 26 so that it can hold all alphabets. In our example, we just have 3 characters, so let us assume we have 3 characters. See, and the other one is letters. So for every substring we find, we're gonna update this letters variable, and we're gonna have a hash map. So in our hash map, we're gonna store the substring and its occurrence. So for every substring we check, we're gonna update all these variables. So first, let us have our pointer I here at A and J also here at A. So we check whether our A satisfies this condition or not. A is not satisfying any of this condition. So move the I pointer to next alphabet. So now our I is at second A. It is checking whether A is satisfying any of this condition or not. It is not satisfying the condition, so move the pointer to the next character. So far we have crossed two A's. So first, while we were at first A, we should have updated the A to 1 and the letters to 1, because the letters will update only if we find a unique character. So far we have come across two A's, so I'm updating A to 2, and now our I is at B, so we found one B and it is a unique character from the substring, so I'm updating the letters to 2. So now let's check whether from I to J it forms a substring or not. Yes, the I to J, it was AAB, which satisfies all three conditions. So now I'm adding AAB to my hash map, and I'm incrementing the counter to occurrence to 1. Let's move the pointer I to the next character. Now I is at A. We'll update the values here. Now we have 3 A's, so I'm updating this to 3, and 1 B as usual. There are no unique characters, so letters will be the same. Let's check whether the substring from I to J satisfies the condition. The letters are 2 maximum letters, and the minimum size is 3 satisfied, and the maximum size is 4 satisfied. So we are adding the character A, B, A, and the occurrence as 1. So next, since it is moved for 4 characters, there can be a chance that there is a shorter substring between this. So I'm going to move the J to next character. So every time we find a substring, we are going to iterate and move our J. Now our pointer J has moved. So every time we move a pointer, we have to update these values. Now if you see, there is a 1A removed. That is, this character is removed. So now we are going to decrement the character from the character array. So now our A becomes 2 and the letters become is still 2 because A did not move to 0. If the A moved to 0, then the A is completely removed from the letters. Then we have to make the letters also decrement. In our case, we still have A in our substring, so we are not going to decrement the letters. If you see, ABA is again a valid substring that is going to be added in our hash map. So our pointers keep on moving. So for every movement, we update these array and the letters by incrementing the characters and incrementing the letters if it is unique, and decrementing the characters and decrementing the letters if the array becomes completely 0. So all the possible substrings will be added and its occurrences will be iterated. So at last we will find again AAB, and AAB will be twice here, and we will be sending the result as this. So now let's directly go to the coding part and see how we're gonna code it. Here is our previous algorithm. I have submitted the algorithm and it's submitted with 50 milliseconds. So let's type in the second approach and check how long it takes to execute. As I said, I'm gonna declare an integer array ch of size 26 to make the count of the letters in our substring, and a map that is going to store the substrings and its occurrences. And integer letters, and finally number of occurrences is our result, which is what we are going to return. Let's initialize the values of letters, and I'm going to declare 2 pointers which are going to iterate through the string. That is my pointer I and j, which runs through the length of the string. And I'm going to take the character of the string and increment the counter. So we're going to update our characters count in CH and also check if it is a unique character. For that, I'm incrementing the character array for that particular character, and if it is equal to 1, that is it is incrementing for the first time, then it is a unique character. Then I'm going to iterate the variable letters to keep count of the unique characters in the substring. Now I'm going to check whether the substring satisfies the rules. That is, if the letters in that substring is greater than max letters, or the length of the substring is greater than max size. If it violates the rules, then there can be a chance of a smaller substring within that substring. So what I'm going to do, I'm going to iterate the pointer j and move the pointer j, and again going to check if that has a different substring or not. So if I iterate the j, I said, so if in case a, b, b, c, if my pointer j is moving from first a to second a, then I have to remove the traces of first a, right? So in that case, I'm going to remove the traces of previous characters, and I'm checking whether that character completely removed from the substring. That is, I'm going to decrement the character at j, and I'm going to check whether it is become 0. That is the completely the character removed from the substring. If it is completely removed, then we have to remove that letter from our substring as well. So I'm going to decrement the letters and iterate the j. And move to the next letter. So every time we are checking whether the substring is greater than max letters or the size of the substring is greater than max size, we just move the pointer to the next character. Before moving the pointer, we are removing the details of that character from our array and letters. Now, if we found our substring that satisfies all the condition, and we already checked two conditions, if it is not violating these two conditions, then it is satisfying those two conditions. Our third condition is it should be it should be greater than or equal to min size. If that condition is also satisfied, then we're going to add it to our hash map. We took the substring and we're going to add that substring to our hash map, and going to check if that substring is already there or not. If it is already there, we're going to iterate its occurrence. Now we are going to update our number of occurrence, that is our result here, every time we found a new substring. So now once we found our substring, we are updating the hash map as I said, and finally we are going to decrement, we are going to move the pointer j. So as usual, we want to remove the traces of the character where j is pointed, and then we are going to move the pointer. So now we decremented the occurrence of that particular character in character array, and we are checking if that is equal to 0, then we update our letters as well. And moving the pointer j. So now that's all done, we are going to return our result. Yes, now our algorithm is done. Let's run. Yes, accepted. Let's submit. This algorithm is also taking nearly the same time. So thank you.